Okay, in this video we are going to go into the definition of what a tangent line is. I know that this possibly is something that we've talked about before, but now we're going to look at it through the lens of limits, since we know more about limits now. So there's a couple different ways to look at this. First of all, remember what we're looking at is if we have some function, and it's kind of hard to see, but in this first graph, this function is this curved function here in the dark blue. And I want to know what the equation of the tangent line is that only goes through this point a f of a. Okay, so I want to figure out what that tangent line would be. So this definition is saying that the slope of the tangent line, m, is going to be, if I take that point a f of a, and I take any other point on this graph, so this is just x comma f of x, it's some xy coordinate point other than a f of a on that graph. And I do the slope between those two, right? So if I draw a line between those and find the slope, that's what that would look like. y2 minus y1 over x2 minus x1 is basically what we have there. If I do the limit as x approaches a of that, so if you think about that, if this x coordinate goes back towards a, then I'm going to get this second point on this graph to get closer and closer and closer to this first point, which means that if I evaluate that limit, that's going to give me my slope of my tangent line through that point a f of a. The second definition is very similar. I've got a point a f of a, which is this red point on this curved graph here. And then I'm going to take a second point, and the second point is going to be an x-coordinate that we're going to call a plus h. So if this is my x-coordinate a, if I then add a distance h to it, then I have another x-coordinate that I can call the distance a plus h. And if I then do the limit as h goes to 0, so what that means is I want this distance between my first point, which is an x-coordinate of a, and my second coordinate, second x-coordinate, which is a value of a plus h. If I take that distance of h and I make that go to 0, which means I'm taking that second x-coordinate and bringing it back towards that first x-coordinate, then what I'm going to have is, again, the same thing. I'm going to have the slope of the tangent line through just that point a f of a. So this is actually just this function modified, where my second point is not x f of x, it's a plus h comma f of a plus h. And you may ask, well, the bottom, why is the bottom just h? If you think about doing the slope between two x-coordinates of a plus h and a, then on the bottom you would have a plus h minus a, and those a's would cancel, leaving you with just the h. So that's why we end up with that. Both of these definitions are perfectly acceptable when evaluating slopes of tangent lines using limits here. Either one is fine. A lot of times I think you are going to find that this second definition is actually going to be easier than the first one, and it may not seem like that at first, but it will. So I'm going to do an example working through both of these definitions, but I will say for the sake of my videos and what I'm going to be doing, we are going to be using this second definition a lot more, but I do want to show you both. The first one is totally acceptable to use. So we are looking at an equation of a tangent line to a parabola y equals x squared. So it's a very simple function here, y equals x squared. And our point is 1, 1. So that's like a f of a, 1 comma 1. All right. So the first definition, we have the limit as x approaches a of f of x minus f of a over x minus a. And again, this point is acting as our a comma f of a. So in this definition, we would have the limit as x approaches a, and a is 1, right? That's the x coordinate that we're looking at is 1. So limit as x approaches 1 of f of x, which is x squared, minus f of a, so that's the y coordinate of the point we're concerned about, which is 1, over x minus a, and again, a is 1. So I just need to evaluate this limit. And again, this is going to give me my slope of my tangent line. Now, if I'm evaluating a limit, I try to just plug the value in. I would get 0 over 0, so I can't do that. So I'm going to do just a little bit of algebra here. I'm going to factor the top. We have x plus 1 times x minus 1. And then on bottom, x minus 1, and the x minus 1s will then cancel, and then I can evaluate my limit, which would give me 1 plus 1, which is 2. Okay, now again, that's the slope of our tangent line. We want to find the equation of the tangent line. So now I'm going to go in and say, well, the equation of the tangent line would be y equals mx plus b. I know that m is 2. I just found that. And how do I find b? Well, I've got the point 1, 1, so I'm going to plug in 1 for y and 1 for x, and I'm going to solve for b. If I do that, I would get b to be negative 1, which means our equation of our tangent line is y equals 2x minus 1. Okay, I'm going to do this exact same problem, but using the second definition. So the second definition was the limit as h approaches 0 of f of a plus h. So that means I'm going to take this function and I'm going to replace the x here with a plus h. Now again, a is 1 here, so I'm going to do 1 plus h squared. Right? That is plugging in a plus h, where a is 1, into the function x squared, a plus h, minus f of a. Well, f of a we know is 1 all over h. Now again, I can't just plug in 0 here. That would give me 0 on bottom. Can't do that. So I'm going to need to simplify the top, which means I just need to multiply that out. So 1 plus h squared would be 1 plus 2h plus h squared, if you multiply all that out, minus 1 over h. Your 1's will cancel. So we have the limit as h approaches 0 of 2h plus h squared over h, and now I can eliminate an h from each term, which would give me the limit as h approaches 0 of 2 plus h, and I can plug in 0, which would give me 2 plus 0, which is 2. Now again, what did we find? We found the slope of our tangent line. Okay, every time we're doing this, we're finding m, the slope of the tangent line. Slope of the tangent line is 2, and then again, your work from there would just follow the same as what you did here. Right? So we've got the slope. I just need to find the equation of the line. Again, we get y equals 2x minus 1. Okay, so again, that's using both definitions. Both are acceptable. I know in this problem, it seemed like this first one was easier, but I will warn you that's because this function was quite easy. Okay, so if this function is a lot more challenging, the second definition is actually probably going to be a little bit easier. Okay, so what this is saying here at the bottom is just kind of an overview. The equation of a tangent line, the equation of a tangent line y equals f of x at a point a f of a is a line that goes through that point whose slope is equal to the derivative, which we'll talk about in our next video, f prime of a, the derivative of f at a. So again, we will talk about that in the next video, but that's what we're really finding here, is we're finding the derivative at a, which is going to give us this slope, which is 2. Okay, but we're looking at that through the lens of limits.